RT331, assessing the maturity and accuracy of FEED to support phase gate approvals. RT331 will discuss the impact of FEED maturity and accuracy on project performance, with savings up to 24% in cost. Further, this team has developed a new tool, the FEED Maturity and Accuracy Total Rating System, or FEED MATRS. RT331 encourages both owners and contractors to use the FEED MATRS tool throughout front-end planning as a decision support tool in the FEED maturity and risk assessment process. Here to present their findings are G. Edward Gibson, Jr., Director, School of Sustainable Engineering and the Built Environment, Arizona State University. Rob Garrison, Baton Rouge Operations Leader, Hargrove Engineers and Constructors. Matthew West, PE PMP, US DOE. Mark Balchezik, Manager Cost Estimating, Chevron. Eric Oxner, Project Manager, Georgia Pacific Chemicals, LLC. And the moderator for the panel, Stephen Cabano, President, Pathfinder, LLC.
Thank you, and thank you for allowing us the time to present our research findings, and the tool that, that we've developed over the last several years of our effort. As we progress through this, our mission was to evaluate the quality of the engineering deliverables for phase gate decisions. So from an owner's perspective, are we developing the right level of engineering, not only completeness, but the quality of the engineering as we go from phase to phase, with the primary focus being, the authorization phase for execution. So the team kind of evaluated a lot of that, and we'll go through our process and so on. But the end result, we developed a front-end engineering design maturity and accuracy total rating system, long word, but the acronym is FEED MATRS. And we'll go through the value proposition, if you want, for the FEED MATRS tools as we go through the presentation. The big value benefit here is that through the research and through some of the actual application, you'll see that we tested it on a number of projects throughout the industry, is that there is a 24% differential from projects that are at a low maturity, low accuracy to a high maturity, high accuracy from a cost standpoint. And that's an enormous value difference from an owner standpoint, who's looking at either approving projects as they go through that phase gate into execution, or potentially using the gate for what it's meant to be and saying, no, we're not ready yet, or we don't want to progress our project through that transition. So before we get started, let me reintroduce the panel. My name is Steve Cabano, and I'll be doing an overview and moderating the session. Mark Boljasak from Chevron, he'll be providing definitions and a little bit more on the terminology we'll be using. Ed Gibson from Arizona State University, Ed will be doing a lot more about the research and how we got to some of the conclusions and the tool. Zach West from Department of Energy. Zach's going to actually do a kind of a test drive through the tool, give you an idea of what it includes and how it functions. And then Rob Garrison from Hargrove and Eric Oshner from Georgia Pacific, they'll be giving us testimonials where we've actually applied the tool and the approach to projects that they've been involved in. So, and then I'll actually close the session up with kind of a closing set of comments, but also Q&A for you all to kind of challenge some of the aspects that you heard. If you take a look at the representation on our team, many of them are here today. It's an awesome representation of both owners, contractors, as well as consultants and academia. And to our calculation, it represents roughly 15% of the CII membership community. So, pretty strong representation of you all in the audience. So the problem statement, if you think about this, the idea of the engineering deliverables that we use to make decisions on whether a project moves forward, part of it is in support of the cost estimate that goes along with those engineering deliverables. All right, so as we progress our engineering deliverables, our cost estimate should be improved as we go along. And at the authorization step, we're looking for plus or minus 10 to maybe 15% level of accuracy that is supported by a certain level of scope definition and quality of those deliverables, engineering deliverables. So what we've used up to now has been the Pdri. And just for a show of hands, and I can't see, but how many people are familiar with the Pdri? Should be a pretty good cross-representation. Yes, right? So fantastic tool, been utilized for a number of years in the different industries. And we're going to focus on the industrial industry sector. And the application of that Pdri tool has allowed us to evaluate whether we're ready to progress or not. But even with that, we don't seem to be hitting our cost and potentially even our schedule expectations as we enter into execution. So the question for us as a research team was what? So the common perceptions, or some of the common perceptions, if you take a look at this term that we called FEED, and you try to put a definition to it, I bet you if I asked this group here, we'd probably come up to 15 to 20 different definitions. So one of the things that we had to do is to define what FEED is. What is that front-end engineering design, and what is the characterization that we're looking for from a standpoint of the engineering deliverables, right? The other aspect is if we take a look at actually who is doing that FEED work, most of you owners, and I'd venture to say all the owners in the audience here, we don't do FEED, right? We contract that out. And then we have to communicate to those representatives, those contractors, engineering organizations, what level of engineering or what level of definition we're looking for our particular project authorization. And it differs between owner, difference between industry, and so on. So we've got to come up with a methodology on how to measure both the level of completeness of the engineering deliverables, but also, and probably more importantly, is the accuracy. Okay, and that was, if you take a look at the multi-dimensions that we're looking at, the Pdri provided an excellent methodology for the maturity aspect. Right? Those of you familiar with the Pdri, it's basically measuring how far have we progressed those deliverables through our front-end efforts. But what we really needed is another dimension, right? And kind of as an analogy to this, if you take a look at these three circles that are on the left-hand side here, are they really circles? With one dimension, they all look like circles. If you look at the P&ID to the right, gets a pretty good understanding of equipment, piping, and so on, but we don't understand the clashes and the interfaces and so on. So what we do need is this second dimension to allow us to kind of see a better perspective of where we are. And that's what the accuracy part of our measurement evaluation and the tool that we developed is you see the three circles. Well, yeah, one is really a circle, but the other two are not. One's a sphere, one's a cylinder. And with the added dimension of a 3D model, you kind of get an idea of where your clashes are in that perspective. So that's, from an analogy standpoint, that's where we're going with the discussion that our panel will go through here. So the results of all of this are the FEED MATRS tool, but we're going to give you kind of the pathway that how we got there, and then give you an example of the application of the tool as we progress. So to get us a few more definitions and terminology, I'm going to hand it over to Mark, and he'll take us through that. Mark?
Great. Thanks, Steve. So I'd like to get started with a general grounding in front-end planning and front-end engineering design, or FEED. So we'll try this again. It's hard for me to see. But by a show of hands, how many out there have a gated front-end planning process? So quite a few of you. So you know that front-end planning is the process of developing increasingly more detailed information to support decisions to maximize the potential of your project going forward. And phase 3 of front-end planning is detailed scope, of which FEED is simply just a part. So based on FEED development and cost and schedule predictions, owners want to make informed decisions as to whether or not their project should go into detailed design. So therefore, we need a clear definition of what FEED is and a really good understanding of what maturity and accuracy is in order to improve that overall decision quality. So really, for the first time, we feel that our team has developed a standard definition for FEED. We've tested it in our research and our surveys, and we've established it as the engineering scope and the associated deliverables that define the physical project scope. So there's the formal definition that you'll see. It's a component of the front-end planning process performed during detailed scope, consisting of engineering documents, outputs, and deliverables for the chosen scope of work. So our surveys have also confirmed the industry rule of thumb for completion of FEED as being approximately when 30% of the engineering hours have been completed. And this also aligns with the Association, catching a cold, the Association for the Advancement of Cost Engineering International's maturity level range for project definition deliverables that support Class 3 estimates that a lot of us use to support project authorization. So this has established FEED as the foundation of the overall project definition package, which obviously includes the engineering deliverables, the cost estimate, the schedule, the execution plan, among some other things. So therefore, a higher understanding of the maturity and the accuracy of these deliverables should result in more predictable costs and estimate schedules and improve the phase gate decision quality. So like the definition of FEED, we leverage surveys and workshops to come up with definitions for maturity and accuracy, since they're both required for an effective FEED to occur. So for maturity, we came up with basically the degree of completeness of the engineering deliverables. And for accuracy, it's the degree of confidence in that measured level of maturity. And as Steve said before, it's these two perspectives together that give us that additional clarity on whether or not we have a quality FEED. So we set the definitions. Now we were tasked to come up with identifying some objective ways to evaluate each one. So for maturity, we started with CII's Project Definition Rating Index for industrial projects, because it's already a widely used tool to evaluate project scope definition. However, you're going to see, as the rest of my colleagues talk, we've improved the objectivity of the scoring. We've created distinct descriptions for each definition level. Okay, and so for accuracy, we identified assessment criteria that evaluates the impact of the people, the teams, and the resources on the FEED maturity. So diving down into Pdri, we identified and chose 46 elements that are aligned with the definition of FEED that we created. So when we went out in the survey and we did some ranking, here's the top 9 elements, some obvious ones you would expect to see, right? P&IDs, project design criteria, capacities. And similarly, we had derived 27 factors for accuracy that can be grouped into 4 different types. Project leadership team, the execution team, management processes, and resources. And again, the survey said top 5 items, and I'm relieved to see that the number 1 item was technical capability of the team. That didn't show up as number 1, I would have been alarmed. So our team feels that we did a really good job identifying these accuracy factors, and some of the research has proven that it applies to all projects in all sectors. So I'm going to turn it over to Dr. Gibson to talk a little bit about the research. Ed?
Thanks, Mark. Good morning, CII. Good morning, Ed. I love you. I've been here 26 years in a row, so I can say that. So I'm going to talk a little bit about our research. This is an overview, but I wanted to give you a feel for what we've done and then tie into that 24% that we talked about earlier. As part of our research, we had a great team, did an outstanding job, first of all. We had 17 people at our meeting on Monday. That's after 2 years. So we had a really good group of people working together. We used a multi-pronged approach for our research, and we used part of the research to inform the work that we did early, and then we did use part of the research to actually test what we had done, which is the way we like to do things. One thing to note here, we actually tested the tool out on 33 completed projects worth about $8.9 billion. And then we also tested it out on 11 in-process projects after the tool had been developed. So the tool has actually been vetted in the industry. So let me talk a little bit about how we did all this. We started out framing our study. We used a lot of literature for that. We had done a good bit of work in industrial Pdri. I was one of the developers of that tool years ago. There was also a lot of good work that had been done on alignment during the front-end planning process. And we also had some great work done by Dr. Oberlander on early estimating, as well as some work on the shutdown turnaround alignment review tool as well. So we had some good baseline framing of our work. We spent some time in our team actually developing an initial definition of FEED. We sent that out to the industry within CII. We got a number of surveys back. About 81% of the people who responded said that's a good definition. They had suggestions. We got suggestions from others. We vetted those, updated our definition of FEED, and at the same time, we asked them how they were doing front-end engineering design in their organizations. So that started out and gave us a really good path forward for our beginning effort. As I said, we had a strong foundation. We had the Pdri for industrial, which has been used for about 22 years. We had a good bit of work and literature around accuracy, as I mentioned a moment ago. And we divided our teams, our research team up into sub-teams, and we spent about 8 or 9 months going through the FEED deliverables in the Pdri, the engineering deliverables in the Pdri. We picked 46 of those. We also developed a number of accuracy factors that we felt were important based on the literature in our surveys, and we developed a working draft. So 46 engineering elements, 27 accuracy factors. As we had done in the past, we felt like we needed to have this vetted by industry, and so we set up a series of workshops to do that, geographically dispersed. We wanted to have owners and contractors involved in those workshops, and we wanted to have people who had a lot of experience. And as you can see here, we were able to get that as we went through those workshops. During those workshops, they actually helped us rank the accuracy factors and also vet the maturity elements, and also providing us with input into our evaluation methods. So we got completed projects and also volunteers to actually test this tool out as we went forward. To actually look at maturity and accuracy, we developed a 2x2 matrix. You can see that here on this slide. And that 2x2 matrix allowed us then to use those two dimensions, the extra dimension that Steve talked about earlier. You'll see this on this graph. You'll see that on the y-axis is a maturity score from 0 to 100, or from low to high, in this case with a little different scale. And on the accuracy score, again, from low to high in terms of accuracy. So if you're in the upper right quadrant, high maturity, high accuracy, that's where everybody wants to be, right? I mean, that's where you'd like to be in your project. You'd like to have a well-defined, mature FEED that we know is accurate. Of course, if you're in the lower left quadrant, how many of you are in that a lot? Then that's probably not where you want to be, but sometimes you find yourself in there. And we'll tell you what that means for you, by the way, in just a moment. If you're in the upper left, you're highly mature but low accuracy. So we've done a lot of work. We put teams together. Maybe they don't have a lot of experience, they don't have a lot of time. They've checked all the boxes, but not quite as accurate. Anybody ever have that happen? And then in the lower right quadrant, you'll see where we have a highly accurate approach, the right structure for what we're doing, but we haven't quite gotten there yet on the maturity. Maybe we haven't been given enough time, or maybe we've had some late scope changes that have caused that. And Zach's going to share something on that a little bit later. We developed some threshold values, and these were developed after we collected data using a stepwise sensitivity analysis around p-values and cost performance. And I can talk to you about that later if you're interested. But the threshold value for accuracy was 76. Threshold value for maturity was 80. We collected data during our workshops. We asked people to bring projects to us. And not only did they bring projects to us that had the ability to measure both accuracy and maturity in our workshops, but they also had completed information. So these projects were done. And one of the interesting things is we used our metric that we had developed for both maturity and accuracy, and you can see here that we had a wide dispersion of maturity and accuracy scores. So each one of these dots represents one project. And you ask yourself, well, so what? What does this mean? Well, the projects that were in the lower left quadrant, where you may find yourself a lot of time, on average were 22% above their targeted estimate that they submitted at the authorization stage. Anybody ever been there? Maybe so. Upper left-hand quadrant, a little better, 6% above budget. Yeah, that's pretty good. Maybe not as accurate as we would like, but if you look at the upper right-hand quadrant, those projects on average were 2% below budget. So 2% below budget versus 22% above budget. My math's right, that's 24%. We're good. So where do you want to be? I think we all kind of see that. We knew we had a pretty good tool. We had it developed. We wanted to try it out. We tried it out on 11 projects. Actually, we've gotten 15 now, but we didn't have time for press here. Over $5.1 billion. Those projects were evaluated by the integrated project teams within those organizations that volunteered and facilitated by our research team members. You'll hear about a couple of those a little later. In each case, they identified gaps in the planning. The teams felt that it added value to their project because it identified risks that they had, and we really didn't have a lot of changes to make on the tool. They felt like it was really in good shape. It takes about 4 hours to do maturity and accuracy. This is the same plot I showed a moment ago, but we added the in-process projects in here. What you'll notice is that we had some projects in the lower right quadrant when we did that, and we'll talk about a couple of those a little bit later. The distribution, North America, about 8 other countries. I think we're adding 3 more countries with the new data that we've received. Completed projects are red. The in-progress projects, I don't know what that color is. Looks like kind of gray or something from my perspective. We got projects and data and input from 62 organizations. That's pretty extraordinary in 2 years. And if your company, organization provided us data, then we're very, very thankful. It's the only way you can get research done at CII is to get people to be involved. So, we took an existing tool, we innovated around that existing tool, the Pdri Industrial, we transformed it into a 2-dimensional tool, and we think it's going to disrupt the industry. You can see a lot of other things that we did here that I didn't talk about. The one thing that I would say is that our tool has been proven. Come out to our booth later on, take it for a test drive on your next project. I'll be followed by Zach. Zach, take it over.
Thank you, Ed. As one of the co-developers of the Excel-based tool that went with our research, I look forward to giving you a very short overview on this. The tool itself is set up to help with facilitation, recording your comments and your assessments, and providing reports to support project management decisions. It's ready to use now. It can be used at any phase throughout front-end planning, and we'll move right into it. To start this tool, go to the setup page. When you enter your project data, it goes throughout the tool. The maturity and accuracy options are there to select. You can do one, other, or both. There is a place to select a level of detail. There are comments embedded in many of the cells within the Excel tool, and you can have the summary version or the full detail version. You have reports you can select. Within those reports, you can come back to this page, turn them on and off. And since, as many of us do, we go around and have to hook up to the computers that we have ability to quickly adjust the zoom on these different pages to support your effort. The workhorse of the tool are the maturity and the accuracy worksheets that are in with the tool. There are 3 areas of the maturity section. The elements, the 46 that have been discussed, are all listed here. To the middle section is an assessment area where you can enter a raw score or put in comments directly. It's useful that way if you're going to use people have printed definitions of the in front of them, and you're just using this to record and memorialize the score. And this section to the right with the weighted averages, which you would generally hide during facilitation to help reduce bias, but show at the end to produce your scores and summary. There is a facilitation mode within this tool. If you double-click on any of the elements on the maturity sheet, it'll take you into the facilitation mode. To the left, it provides the element description and some additional comments, as well as some comments for revamp and renovation. At the top, though, as was discussed, there's been an effort to put down better definitions for those 46 feed elements to include what a 2, a 3, and a 4 are. And those that have worked with Pdri know that there can be some debate there. One of the challenges that we've seen that this tool helped with is it does provide better consistency when using it. Below the bold area are some expanded definition to help in your facilitation. An example, using the G8 plot plan, opportunity to take a look at what a number 1 and a number 2 are, as well as a little bit of the detailed description below. At the bottom is some more definition description towards renovation and revamp projects. And at the bottom of the sheet, a place where on the facilitation sheet, a place where you can put comments, mark your assessment, move forward and backward in this facilitation, and return back to the maturity assessment sheet. For accuracy, very similar design. 3 sections, works the same. One difference with the accuracy, though, is that this tool can apply to all sectors and all projects, whereas the maturity were a little more aligned to the industrial. The accuracy has a facilitation sheet also. This sheet works very similar. There are 27 factors here versus elements. If you double-click on a factor, you arrive at this sheet. Ability to take a look at high-performing or meets most. On this particular one, the leadership team's previous experience. The definitions are typical throughout all 27 factors. To go into the reports, I'm going to use an example from one of our Department of Energy programs that Rob Garrison and I recently did a FEED MATRS facilitation on in March. The program has 5 projects, 3 in Louisiana, 2 in Texas, worth about $1.4 billion in cost estimate at this point. The majority of work is revamp and renovation. The scope is listed on the left of the slide. This project actually has just gotten through the defined scope phase gate and is moving into detailed design. We had an opportunity to do a facilitation with them just as they were heading that phase gate. One of the challenges that we found that they had is that they were a little bit below the maturity target. Well, there was about 10% scope that came into that program from another project that got realigned, and the team was able to identify that that scope, a late addition, had some gaps that they had to work through. And it helped, they were able to identify that and help identify the issues they had to do to correct that. The score is presented here normalized because there can be elements, of course, that don't apply to the project. On the accuracy discussions that we had with them, they were rated as a very highly accurate team, and my colleague Rob will discuss that a little bit more in the testimony. One of the aspects of this tool, that graph that was displayed by Ed, is also built into the tool to give you a quick visual of where you exist. Again, for the Strategic Petroleum Reserve, or SPR, they were highly accurate, but a little bit below where they wanted to be on maturity. One of the reports that they were able to drive out of this tool was their gap analysis report. All the gaps, it's by default set to 3, 4, and 5 for maturity, and meets some, needs improvement, or not acceptable for the accuracy component. And those are all adjustable for the user. But with that, they were able to generate a corrective action plan that they were able to work on. So with that, I appreciate this. Our tool is available to be looked at in further detail out in the hallway. And with that, I'll turn it over to Rob on testimony.
Thanks, Zach. Hello, everyone. I'm going to speak briefly about my experiences using this new tool. So I was involved in facilitation of 2 separate FEED MATRS sessions conducted for in-progress projects, where both projects had just recently completed FEED. The first project was an air system upgrade at a petrochemical facility, a project scope that included new air compressors, accumulators, and a revamped header system, with approximate total installed cost, or TIC, of $10 million. The session was attended by the engineering team's project manager and discipline leads. The second project was the SPR crude oil transfer and storage project mentioned previously by Zach. The scope included multiple pump and valve stations and miles of large bore piping with approximate TIC of $1.4 billion. This session was attended by the owners, project management team, subject matter experts, as well as the engineering contractor team's project management team. So from a few facilitation and functionality standpoints that I wanted to share, the first of which was the benefit of having a summary description for each definition level of the maturity elements. This quickly aligned the team on the appropriate selection during that effort. And also, the clarification of having reviewed and approved deliverables was the primary differentiator between level 1 and level 2, and this quickly aligned the team on the appropriate selection. So while there was this initial concern that the accuracy session would be a team grading exercise, it was actually well received, and open and honest feedback was given, and it provided confidence to the teams moving forward. And lastly, the 0 to 100 scoring system was very intuitive, and the quadrant plot provided a quick visual on how the project stacked up against other projects. So now from a little more project-specific standpoint, there were several common takeaways, and again, from the previous sessions we discussed. So both projects had recently received funding for the next phase. However, it was clear they didn't have quite the same level of FEED completion. And this highlights there's not a one-size solution for project success, and a need to have a customizable FEED evaluation tool. And our tool, FEED MATRS, provides this with adjustability and weighting so that owners can place emphasis where desired. And so it was noticed that there were a couple of items and more that were seen to have minimal activity during FEED, one of which was piping systems requirements, which included piping stress analysis, and then also specialty items list developments. These, along with others, were captured in a gaps list generated in session by the tool, and then immediately distributed to the teams. As a result, the SPR team created a corrective action plan, and then also scheduled status review meetings. And then finally, during the accuracy exercise, it became obvious that there was some funding disruptions at the end of FEED. And this was preventing the, progressing the maturity of some late added scope, and of course was having a little negative impact on the evaluation score. And this is a good example of how utilizing FEED MATRS over a portfolio of work can really identify trends and areas of improvements. For this, instance, maybe planning for some bridge funding or maybe some additional duration for the FEED effort. So ultimately, the use of this new tool was very much a success, and I'm going to be utilizing in the future and be encouraging others to do the same, and hopefully I can encourage you as well. So turn it over to Eric for additional testimony feedback.
Thanks, Rob. So I recognize we're right before lunch up here talking about FEED MATRS, and the irony is not lost on me, so this will be a brief testimonial. So like companies often do, we approach this tool very pragmatically with a single question in mind: how will this create value for us? And we came up with 2 ideas. So first, we thought that by giving better definitions to the project teams, it would allow them to understand in process where they were and ultimately create better deliverables. Second, we thought that using the assessment tool early on in the process would allow us to make sure we created a better environment for the teams to be successful as they were working on FEED. So we then set about to try and test these 2 ideas. So to test the first idea, we took a structural steel renovation project at one of our facilities. This project was right at the end of phase 3, and it was getting ready to go for full funding. We gave the project team the maturity assessment, but we did not give them the definition. So what they got was very similar to what they'd gotten on the Pdri in the past, and we asked them to do a maturity assessment. They came back with a score of 82%, and they felt like they were ready to go to full funding. We then gave them the definitions, and we asked them to please go back and repeat the exercise. This time they came back with a score of 70%, and they said they would like a little bit more time to work on some of their deliverables. And then as the tiebreaker, we did a full facilitated session with the project team and the stakeholders, and we did the maturity assessment. This came back with a score of 71%. So this little exercise taught us that the definitions made it so that the team did a much more realistic and consistent maturity assessment, and they understood where they were. As a result of the facilitated study, we decided to delay the approval of this project. We gave the team more time to go back and work on their deliverables, and they ultimately uncovered additional scope that they had missed. This additional scope increased the budget of that project by 18%. But by identifying that before we had approved the project, we avoided a difficult situation where we approved a project with inadequate funding. We believe we saved this project several months of going back and getting through reapprovals and additional funding. To test our second idea, that we could try and create this better environment by using the accuracy assessment, we took a team that was just starting the FEED development on a project down in Argentina. There was a joint facility where they were separating into two separate facilities, separate infrastructure, separate access points, separate utilities, etc. So at the beginning, we sat down with the project team and we did an accuracy assessment. And that assessment uncovered some weaknesses in the environment we had created. Here is the top 3 items from the gaps report that the FEED MATRS tool produced. From these gaps, we were able to identify issues early on and take corrective actions before these problems and weaknesses turned into significant problems in our planning process. So from this, we were able to introduce additional management reviews during the process because we recognized some of the inexperience of the team. We were able to supplement the team with additional staff local to Argentina because it was recognized that there was a weakness in our understanding of the codes and standards in that area. And finally, we were able to introduce additional construction reviews because we recognized that the team was underrepresented by contractors. This project is now routing for full approval, and there was no question on the review team's mind that those changes that we made early in the process resulted in a better FEED and ultimately will result in a better project. So I'll now pass it back to Steve for some concluding remarks.
Okay, thanks, Eric, and thanks to the team. Before we get going on questions here, I would like to just provide a summary of, I think, where we've been over, for us, the last couple of years, but for you, the last 30 minutes or so. The first aspect was, defining FEED and what that means. And, from Mark's presentation, it's what we defined it as and was tested through the industry are the technical or engineering deliverables required to get through the front-end process, right? So there's a lot of other things that support the overall effort moving forward, like the execution plan and your estimate and so on, but we focused on the technical deliverables as an aspect of FEED. The second part was on maturity, is using something that was already accepted, and as I said, many of you have adopted the Pdri, but to build consistency was to develop the additional criteria for the 2s, 3s, and 4s, so that we can build a consistent scoring process for that level of maturity that we're looking for from a FEED aspect. The real added effort here was on this accuracy piece, right, is the ability, and it's hard to measure accuracy, right, unless you redo the engineering. So these are the inputs to accuracy. So it's the, do we have enough time? Did we give the people the right information? Do they have the right supervision? Do they have the right leadership? Those aspects that contribute to the probability of you achieving a high-quality FEED, which results in those numbers that we talked about before. And the last aspect here is combining all of this into a tool that's easy to use and is tested. And I think that's the critical aspect here, is that we took a good portion of our allowed time for this overall effort to go out to you all in the marketplace and challenge this, challenge some of the aspects of the definitions we were using, but also the tool and application of the tool, which led to, where do you want to be? From an aspect of a low maturity, low accuracy, to a high maturity, high accuracy, And that 24% cost deviation is enormous. And again, if we follow our owner front-end processes, it's whether projects move forward or do we spend our money elsewhere from a standpoint of our evaluation at that project authorization level, or do we recycle, do a little bit more effort, mature them to a greater extent so that we have better, and I think Eric mentioned that in his testimonial, spend a little bit more time and get better numbers. Doesn't mean the number is going to be the same from an overall cost standpoint, but it's a more realistic number based on the evaluation. Okay? So before we get started, you should all have a pamphlet on your table. This gives a real quick overview of what we've just talked about, but on the back side, there's a QR code or a QR reader and a URL that if you apply either one of these, the tool is there for you to utilize right away, but also the research, and there's quite a bit of research that went into this. So please feel free to access that and test it within your organizations. I would like, if the lights can be turned on, we'll field questions here. The microphones are in the middle of the room. We would ask that if you mention what your name is, your company affiliation, so owner, contractor, academia, whatever it might be, and if there's any specific individual within the panel that you're directing your question to, please let us know. If not, shoot them at me, and then we'll field them from there. Yes?
Yes, Charles Ellis with Potash Corporation.
Hi, Charles.
How do you see the relationship between PDRI and FEED MATRS? And in other words, ultimately, do you think FEED MATRS would replace PDRI?
Yeah, I'll take this one first, and then I'll let the panel add. So again, what we did is we focused on the technical deliverables. That was our charter, right? So all of the PDRI elements have not been evaluated yet. We happen to have a little bit more time and money, and we are going to do the remaining elements of the PDRI. So in essence, at the end, yes, you could replace the industrial PDRI because has not been done for the other PDRIs. And by the end of this year, you'll have that. And I don't know if any of Ed, you want to add anything there?
So I think there are a couple of things that it's going to provide value for. I think, one, we're going to do the other 24 elements, and right now the plan is to put them into the software that it doesn't have it right now. So that'll provide some value. Another thing is the descriptions of the definitions as you go through the PDRI assessment. If you're a facilitator, it provides a lot more of an objective evaluation set of criteria for you to actually go through and determine what the level of definition is. That adds a lot of value to the process. As Steve said, it's only for the heavy industrial PDRI. There are 4 other PDRI tools that are out there. Eventually I think it probably will take over the large project version of the PDRI. So excellent question.
Okay, is there any others? I can't. Yes?
Hi, Steve. Rex Phillips from Eli Lilly.
Hey, Rex.
As you talk about PDRI, obviously, we do that in multiple steps as we go through. Is it envisioned, and did any of the sample projects do multiple FEED MATR sessions? Yes.
So, and it's a great question because some of the questions, especially when you're looking at the accuracy elements, they what do you want to call it, prompt you for what is required to make sure that you have a good team, a good environment for you to execute the FEED activities. So our vision is, and it's similar to the PDRI, right? That you could do this by phase and actually early in the phase, before you get to the phase gate approval, to identify what is needed by the end of the phase, but also the environment that those people need to work within to support those deliverables moving in from phase to phase. So we do see it being utilized in several steps. Yes?
Good morning, Trey Miller with CDI Corporation. Quick question for you on the engineering side. Did you take into consideration contingency in utilizing the tool for financial contingency planning on any of the projects, and is the contingency counted at 24% that you, savings you showed?
Yeah, I can
Okay,
answer.
I'll let,
So we did ask about contingency. We took the contingency out when we did the comparison. So that's a straight up difference right there in terms of target estimate. Certainly, if in some of those projects that were in the lower left quadrant, if they had actually done an assessment, you know, early on, they may have added additional contingency in if they realized they didn't have, you know, the right level of definition. So, but the number that we showed was the targeted estimate versus the final constructed cost and what the difference was without any contingency thrown in it.
But I mean, also, I mean, from an owner's perspective, I think that there was value in looking at the risk of the project, because sometimes you're in a situation where you're going to move forward on a project, even if you're not at the high maturity, high accuracy, because you have some deadline you're working against. And yes, from the owner's standpoint, in our organization, we are looking at that as an indicator for should we have additional contingency.
And what I would say is that having looked at contingency tied to front-end planning over the last 26 years, you know, with a number of projects that we've done, the level of contingency held has no relationship to the level of definition of projects. Many times it's just pulled right out of the air or some other dark orifice.
no. Thanks. Yes.
Michael Abraham from the University of Wisconsin-Madison. I noticed that having a high maturity and high accuracy feed affects cost performance. However, what about schedule performance and quality performance?
Yeah, we knew that was going to come. So we actually calculated schedule performance on the projects. What we did find was, and it wasn't a tremendously strong relationship, but we found more of a relationship between accuracy and schedule than between maturity and schedule. We did have a linear relationship, and that's in the research results that we will publish. One of the things about that, I mean, it makes sense when you sit back and look at it. If we get into a situation where we don't have a good environment for the front-end planning to take place, and the feed goes into detailed design, then that would obviously probably lead to some kind of schedule slowdown because you're having to go back and redo a lot of things. So we did find that. It's not a major finding of a study, but and we speculated on a lot of different reasons why that came out. It was just the data that we got. It's a good question.
Thanks. Is anybody, nobody on the, yes?
Scott DeVille with Huntsman.
Hey, Scott.
Did you cross-reference any of the data you have for these projects to the Pdri scores?
Well, I think, Eric, that's exactly what you did in the first part of your, the first project, right? Where you did the Pdri flat out.
Yeah, so I mean, we were trying to get an idea of how it stacked up. So on the structural steel project that I mentioned, originally what we gave them was just a Pdri for them to go and do their own, their own assessment of where they thought they were, and then compare it to the score we got when they used the definitions to see if it made a significant difference. Because as a company, that's what we were trying to figure out. Is it worth us switching over? Will it make a big difference? And on the test case that we did see a significant difference. And ultimately, the facilitated session, which is the one that we tend to put more confidence in, seemed to stack up very closely to the team's use of the definitions, which I think to us communicated a level of repeatability that I think adds a lot of value.
And I think to answer the second part of the question, we didn't do the entire Pdri assessments for the projects that we looked at because we were looking specifically at those engineering deliverables. There are 24 additional elements that we didn't go out and capture at that point. So we didn't do that.
Do you plan on doing it?
You know, given the right environment and funding and all that kind of stuff, we might.
Okay, I think we're out of time. Appreciate your time. Please go and visit our table out in the hallway here. There's a live version of the tool, and again, feel free to download the information at any point in time. Thank you.